Hello, welcome to Variable Exponents here today. This is kind of a workaround to logs. If you're looking at these two here, 2 and 2, same base, when you're looking at your same base and you can get your bases to match, you can essentially solve for your exponents without having to use logs to get them down out of that exponent position. So looking at this, I see 2 to the 5th. Well, this is the same base, so x must equal 5. When you have your bases that match, you are able to set your exponents equal. So let's say I had 2 to the x equals 64. Well, can I get my bases to match? I see this smallest base of 2 and I'm asking myself, hey, can I rewrite 64 as a base of 2? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 64 is actually 2 to the 6th. I just rewrote 64, and this is 2 to the x. Since my bases are the same, I can set my exponents equal. X equals 6. We can apply all our properties of exponents. You should be pretty comfortable with those. If not, please check out the properties of exponents video. So let's look at something else here. How about 16 to the 2 plus x equals 2 to the 3x? Okay, looking at that, you want to get those bases to match. If you can do that, you can successfully deal with these. So I'm looking at 2. I want to rewrite that as a base of 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 is actually 2 to the 4th. And then I bring along this exponent of 2 plus x equals 2 to the 3x. Okay, looking at this, properties of exponents, you have a power to a power. Make sure you multiply those two together. So my base is 2. I need to distribute that 4. 8 plus 4x equals 2 to the 3x. Bases match. You can set those exponents equal. 8 plus 4x equals 3x. Now it's just a matter of solving for x. So subtract 4x. So 8 equals negative x. X equals negative 8. We're just going to kind of keep on moving through these here. 27 to the 2x equals 81 to the x plus 3. Little preemptive on this line right here. Hopefully I don't run out of room. We'll see what's going on here. So I'm looking at 27 and I'm looking at 81 and I am thinking to myself I need to match those bases somehow. Fortunately, we can rewrite both of those as a base of 3. So 3 times 3 is 9, times 3 is 27. So 27 is actually 3 cubed. Bring down the 2x. Now 81, same process. 3 times 3 is 9, times 3 is 27, times 3 is 81. So you were looking at 3 to the 4th. 81 is 3 to the 4th. Bring along your exponent. And now just multiply those exponents out, so you get 3 to the 6x equals 3 to the 4x plus 12. Set those exponents equal and solve. Subtract 4x. Divide. X equals 6. Whew, fortunately I made it there. Wow. That was kind of nerve-wracking running out of room like that. Woo! All right, let's keep on moving down the line here. 1 over 125 to the x plus 2 equals 25 to the x. Now we need to match our bases and we need to get them in the same spot. So this is down in the denominator. You will need to bring that up to the numerator so they are in the same position. And I guess you could actually move that down into the denominator if that is what you wish to do. So first things first, I'm going to try and match these bases, and I'm thinking a base of 5. So it is 125 would be 5 cubed to the x plus 2 equals 25. Well, that would be 5 squared. Bring along the x. So now I'm just kind of simplifying here. 1 over 5, distribute that 3. 3x plus 6 equals 5 to the 2x. Now I need to bring this 5 out of the denominator position and move it up into the numerator. The way you switch positions or change locations when you're dealing with exponents is a negative. exponent. So if I were to make this whole exponent negative, it's going to move from the denominator up to the numerator. So it is 5 to the negative 3x minus 6 equals 5 to the 2x. Bases match. Awesome. Set those exponents equal. Negative 3x minus 6 equals 2x. Solve now for x. Let us add 3x. Divide by 5. X equals negative 6/5. Leave it open-ended down there at the bottom this time. Learning my lesson. 1 over 9 to the x plus 1 equals the cubed root of 27 to the x. Interesting. I'm seeing a root. Hopefully you are remembering that a root is really just a fractional exponent. So let's start simplifying. I see 9 and I see 27. I'm thinking base of 3 here. Base of 3. So 1 over 3 squared, x plus 1. Cubed root, 27 would be 3 cubed to the x. Okay, we're just cleaning up. So 1 over 3 to the 2x plus 2 equals the cubed root of 3 to the 3x. There we go. Great. So now let's move this thing out of the denominator by changing the exponent. 3 to the negative 2x minus 2. Now this is a fractional exponent. We can rewrite the root as a fractional exponent. So it will be 3, my base of 3. Your exponent is your numerator, and the root you are taking is the denominator. 3 to the 3x over 3. Well, fortunately that little exponent reduces. So really you're looking at 3 to the negative 2x minus 2 equals 3 to the x. Set those exponents equal. Negative 2 equals add 2x over 3x. X equals negative 2/3. Hopefully you're picking some of this stuff up. We're just going to keep on moving through a few more examples here. How about the 5th root of 8 equals 4 to the x. Okay, I'm looking at 4 and I'm looking at 8, and I want to match those bases, so I'm thinking 2. So the 5th root, well, 8 would be 2 cubed equals 4, which is 2 squared, and then bring down that x. Okay, so we can rewrite this here. It is a base of 2. The exponent would be your numerator, and the root you're taking is the denominator. 2 to the 3/5 equals 2 to the 2x. Bases match, so it is 3/5 equals 2x. That is a proportion right there, so one way of dealing with it is to cross multiply and set those equal. 10x equals 3, x equals 3/10. 1 over 16 to the 2x equals 8 to the x plus 2. Bases here of 8 and 16, so I'm thinking a base of 2. So 1 over 16, well, that would be 2 times 2 is 4, times 2 is 8, times 2 is 16. 2 to the 4th. Bring down your exponent of 2x equals 8, which is 2 cubed to the x plus 2. Okay, so 1 over 2 to the 8x equals 2 to the 3x plus 6. Got to get this thing upstairs, so change its position by changing the sign of that exponent. There you are. You can set those exponents equal. Subtract 3x. Divide by 11, negative 6/11. How about 5? 5th root of 25 squared equals 125 to the x plus 1. All right, match those bases up. Okay, so the 5th root of 25, well, that is 5 squared. Bring along that exponent of 2 equals 125, giving me 5 cubed to the x plus 1. So the fifth root of 5 to the fourth equals 5 to the 3x plus 3. Okay, a root is a fractional exponent, so it is 5. Exponents up top, numerator. The root you're taking downstairs, denominator. 5 to the 3x plus 3. Bases match of 5, so now we can set those exponents equal. So 4/5 equals 3x plus 3. One way of dealing is a proportion, so cross multiply. So don't forget to distribute this 5 to all that, giving us 15x plus 5 equals 4. 15x equals -1, x equals -1/15. 1/343 to the x plus 5 equals the square root of 49 to the x plus 3. So I see 343, I also see 49, I am thinking a base of 7. 1/7 cubed to the x plus 5 equals the square root of 7 squared. That's your 49. Bring down the x plus 3. So distribution here, 1/7 to the 3x plus 15 equals the square root, and I don't need that 2, that was just for some visual purposes there, 7 to the 2x plus 6. Alright, so I can bring this thing upstairs by changing its sign. -3x minus 15 equals, okay, remember that 2 is right there, so this is 7. Now we're looking at a fractional exponent. The exponent is up top, the numerator, 2x plus 6. Downstairs is the root you are taking, which is 2. There you are. Now that would reduce if you factored it, and that is one way to approach it. If you don't see that, that's fine. You can set those exponents equal. -3x minus 15 equals 2x plus 6 over 2. Now, it is a cross multiplication problem. So we are looking at -6x minus 30 equals 2x plus 6. Solve that, you're out of the woods right there. So add 6x. We can also subtract 6. X equals -36 over 8. Chop them in half. -18 over 4. Ooh, we can chop them in half again. -9 over 2. And there you go. Those are some variable exponents right there, and I would like you to take a look at something very similar. A lot of people have some issues jumping and bouncing between the two of these. Not necessarily a variable exponent, but it is still it's really just an equation now that you're solving. So we're just going to look at a couple examples. 5 times the cubed root of x minus 3 equals 20. So this is multiplication. Come through first and divide by 5. The cubed root, x minus 3 equals 4. We want to undo this root. We'll undo that by cubing. X minus 3 equals 4 cubed. 4 times 4 is 16, times 4 is 64. Add 3. X equals 67. These are just solving now. Similarly, 5 plus the cubed root of x minus 3 equals 7. That's addition, so undo your addition first with subtraction. Cubed root, x minus 3 equals 2. Cube both sides. X minus 3 equals 8. Add 3. X equals 11. How about 4x cubed minus 6 equals 34? Probably seen something like this before. Let's just isolate the x. So add 6. Divide by 4. undo the cubed with the same root. X equals the cubed root of 10. You may rewrite that as a fractional exponent, 10 to the 1/3. Almost done here. How about 3x minus 4 to the 4th divided by 3 equals 15. First things first, let's undo division by 3. We will multiply by 3, leaving us with 3x minus 4 to the 4th equals 45. Let's undo this with the 4th root. 3x minus 4 equals the 4th root of 45. Add 4. Divide by 3. That could be 45 to the 1/4 power, and that is totally fine. If you had a calculator, you would get a decimal approximation. Thank you very much. Hope that helps you. See you later.